Okay, guys, fantastic. Welcome to our quick update on a brand new mini module on the introduction to the basics of statistics. Now, we pulled this together because, doing lots of Lean Six Sigma training, statistics tends to scare a lot of people. And sometimes really it's kind of getting to grips with some of the fundamental commentary and what is it all about and how to use it. I don't know, we're going to be using this book a lot. The Average is Always Wrong by Ian Shepherd. It's a really, really fantastic book. It's been done incredibly well put together. So we're going to be very, very unashamedly, we've stolen lots of the information from that book. And hopefully it will give you an insight into some of the benefits of really getting to grips with some of the fundamentals on statistics. Now, you can probably tell, hopefully, that I'm not a statistical geek. You need to use data to make really, really good decisions. So what we're trying to do here is introduce the ideas that allow you to understand how to begin to interpret data and how to begin to ask questions. Some of us love data. I'm not one of them, but it's really important we get to grips with it because obviously more and more in our world today is being data-driven. So I want to bring you to a hypothetical kind of retail business example. You can see here down the bottom, we've got the blobs. We've got 8 of them. You'll get introduced to them fairly soon. On the left-hand side there, you've got the weekly spend for each of these blobs in our particular store. And if we jump straight into kind of stats and statistics, let's firstly just plot them on the graph. So here we go, blob 1, blob 2, spent a little bit less, blob 3, a little bit more. Well, blob 4 is probably one of the higher spenders that we've got. We've got blob 5, 6, 7, and 8. So often when you first get into data, you can see we tend to keep data in Excel. We tend to keep it in spreadsheets. We tend not to kind of use graphical representation of that data. So the first thing we've got to get in a habit of is taking that data and making it visible in some way, using some graphical tools such as this chart here to really begin to bring it to life as we go through as well. So this is our data points that we're going to start with today. Now, the first thing we need to think about when you think about this data, and if you guys are thinking about the data, the first thing we tend to always want to know about or we want to calculate is what we call the mean. So the mean, generally what we mean by the mean is what we call the average. So when we refer to the average, we're most likely referring to the mean as well. And you can see here, this mean against all these blobs that we've got on the screen is £73. So this means that the average amount of these blobs spend within our stores on a weekly basis is 73. Obviously, we're not going to go through how you calculate the mean, but you can add up all the data and then divide it by the number of blobs and you will get to this mean. So the mean is the first data point that we really get. And lots of us use the mean or the average. We're always talking about the average when we're making decisions or sharing results with other people as well. So this is what we mean when we first look at the mean. The other thing that we also want to look at is this second line that you can see that's just there. Well, this is what we call the median. Now, often we forget to use the median. We learned it when we were at school, but we tend not to use it particularly often when we're sharing data or explaining things. We tend to always default to the average. But what the median is it's that point where we're halfway up the list. So in this example, it's actually going to be about £76. So what that means is that if we go halfway up the list, we hit this figure of 76. What is great about the median is that it basically is halfway. It's in the middle. So 50% of your people, in this example, our blobs are going to spend more, and 50% of our people from the blobs are going to spend less in this particular example as well. So this is what we're looking for, the median here, so the 76. So we can see there that the mean and the median, they're pretty close, but they're not necessarily the same in this example. And as we say, the mean and the median don't have to be the same. Ideally, we would love it if they were most likely to very, very close to each other, but sometimes they don't have to be the same. And a very, very simple example of this is, let's imagine We've got 9 blobs. They're all spending £1 a week. And then we've got one blob spending £91 a week. Well, the mean spend is £10, right? It's 100 divided by 10 blobs. But the median, that middle number, would only be £1. So we could very, very quickly see there that if we've got a £10 mean and a £1 median, something strange or something interesting is going in our data, going inside our data. A really kind of easy way to look at the importance of this, if you just think about salaries, 10 of us together on the call, think about the average salaries, and then you go and get, an Elon Musk or a Jeff Bezos, and you put them into the mix, and suddenly that average salary for the group of, let's say, 10 of us is going to rocket, and we're all going to seem to come across like multimillionaires. If we looked at the median, however, we would probably get much closer to our salary levels rather than being driven by an outlier or somebody that just earns exceptional money. So this is the reason. The first thing is that when you're looking at data, don't just get fixated on the mean or the average, which we're all very happy with. Begin to interpret what that median is as well, because it already gives us a little bit more information about what is happening. The next thing that we can also look to calculate when we've got these simple data is what we call that range, right? So this is really, really simple, the distance between the highest and the lowest data point. We know what that mean is, so we know where that average is. We know what the median is, so we know what that middle number. And that range is going to give us an insight about how far or how vast that's what the data spread out. If we take the example of, the $1, the £1 and the £10, it's obviously going to give us a really, really big range between £1 and £100 spent, or £97 spent. So that range now tells us, really kind of gives us an inclination of how vast our data is spread around. Is it close together, or is it spread over a large amount of numbers as well? So this is another thing that we can pick up as we run through this. So here we go, look at the mean and the mean and the median. And it's really in these two data sets, you can see we've got a customer data set number 1, pretty standard all around the middle, customer data set number 2. And as you can probably guess, what we're going to do is we're going to have a look at the mean and the median to see what it tells us about the two. Well, the one on the left is just another example of what we've just been discussing. The mean of these blobs is 73. The median is 76.5. So you can see there it's pretty tight, very, very closely related together. If we look at the customer data set number 2, well, it's exactly the same. The mean is 73. The median is 76.5. So when you're looking at your data, if your data looks like the one on the right, you've got a lot more variation going on. You've got a lot of bits and pieces you need to take into account. If your data looks a little bit like the one on the left, the customer data set number 1, you can tell it's a bit closer. It's a bit closer related. So therefore, the way you can interpret that data is potentially going to be very, very different as well. So when we're looking at our data, once again, we've got to be graphical. So make your data graphical. Secondly, make sure you understand what your mean is and understand what your median is. But now we need to go into a little bit more detail to really understand what it is we're really looking for and how we're going to interpret this data at the next level as well. So how do we describe the difference between these two data sets? Well, this is what we call the standard deviation. So you can see here, we've got our blobs on the left, and you can see that they're jumping about, they're spread around a little bit. The first thing we want to do is document that average, that mean figure. What is the average points of this data? And what we want to be then looking at is the question is, how far are those data points away from that mean? So we're looking at these distances you can see there in the red arrows. We want to understand that if they are a long way away from the mean, we're obviously going to have a very high, what we call standard deviation. We'll have lots of variation within our data. If that number is low, then obviously the variation within our data is going to be a lot less, and it's going to be much, much tighter. So when we're talking about the standard deviation, The standard deviation allows us to measure how far spread out our data is from that mean. And that would help us in the previous example to see that even if we've got a mean and we've got a median, which is similar, the standard deviation between those data sets is going to be very, very different as well. The standard deviation is really important. If you think about things like pizza delivery times, really, really simple one. Lots of us have been ordering pizzas with COVID and being locked down. So we've been ordering food in. So let's just imagine we've all ordered a pizza. Now, if this company offers to deliver it to you between 20 minutes and 40 minutes, that gives us a 20-minute kind of window. If they are offering us between 10 minutes and an hour variation, are you happy to wait for an hour for a pizza to be delivered? So once again, just on ordering a pizza, that variation within that data is really, really, really important for us to understand as well. It's really important that we understand how things are going and how things are moving forward. So here you can see we've got very, very carefully put together what is the distance between our data points and our average or our mean in this. And this helps us understand what that standard deviation is all about. So because none of our blobs are actually spending $73 a week, this is the reason we can say, and this is the reason that Ian Shepherd says, that average is always wrong. And that standard deviation tells us by how much. So when you're in your business and you're working in your company and somebody turns around and says, well, the average spend per customer is X, a certain number, then you're starting to turn around and go, right, so the average, but what is the median? Have we got one person that spent $10,000 and one person that spent, and 100 people that spent $10, for example? So this is the reason you can begin to ask the question, what is the mean? What is the median? And then what is that standard deviation? So this is going to help you understand how well spread out that data is, how far that data is away from your average that you're looking at. So really, really important.